This is a presentation of Istio Service Mesh. We will take a look at deployment, practical guide, and running a simple example using Istio Service Mesh. In previous video, which is Introduction to Service Mesh, we have defined the whole concept of control plane and sidecar driving the service-to-service networking, communication, traffic, and security policy is what we call a service mesh. In this presentation, we take a practical look, do a live deployment of Istio, demonstrate Istio security, look at service-to-service communication, and deploy a canary version of the application. The example application, Invoice Manager, is a bunch of 4 independent microservices for generating and processing invoice. Each service calls other's service to complete the workflow. Application is written in Node.js and is deployed on a Kubernetes cluster. Example will demonstrate service-to-service communication, transport security, and silent application upgrade using Istio framework. Application source code and the deployment manifests are available in GitHub repository named Invoice Manager. The link is available in the description. Let's clone the repo to the local working machine using git clone command and view the content of the repository folder. The minimum prerequisite for Istio is a Kubernetes cluster with at least one node, which has a minimum 16 GB of RAM and 4-core CPU. For local testing, a Minikube deployment of K8s cluster will be sufficient. We are not going in details of Minikube deployment, but we will check the configuration before we proceed by running the following commands. Minikube status provides the status of installed Minikube installation. It should be in a running state. Minikube config view VM driver provides the node CPU and memory allocation, together with Kubernetes version. kubectl get po-a provides a view of all running Kubernetes pods in a control plane. Few extra Minikube configuration is needed. On a separate bash shell, start the command Minikube tunnel, which will start a default load balancer which is needed for Kubernetes dashboard and Istio gateway. Let's also enable metrics server and start Minikube dashboard. On a separate shell, type the command Minikube add-ons enable metrics server. This will start a metrics server to capture Kubernetes telemetry metrics data. Then start Minikube dashboard port number --URL. You can give any open or mapped port number. The Kubernetes dashboard can now be accessed from browser. Before installing Istio, create a namespace Istio system. Then add a generic secrets in Istio system namespace. Check the CA secrets by running the command kubectl describe secret key certs -n Istio system. Now download specific version of Istio. We will stick with version 1.18.0 for this demonstration. Add the Istio bin path to system path. We can now install Istio by executing the command istioctl install -y and await for install to finish. After installation is completed, run the command kubectl get all -n Istio system to check all the resources and pods created by Istio. We will create a new namespace called UI and label it with Istio injection enabled. Istio control plane will inject Envoy, proxy to the pods created in namespaces label with Istio injection enabled. Run the following command kubectl label namespace UI Istio injection enabled. Rerun the same command for default namespace also. Then deploy a service account in both UI and default namespaces. The manifest file for service account is already provided in Invoice Manager GitHub repository in the folder SA. Now check the service account created by running the command kubectl get SA for default and UI namespaces. We can now install a gateway for our demonstration. The gateway will be deployed in default namespace with a selector containing name Istio and value as ingress gateway. Traffic will come to gateway before routing it to specific microservices. The manifest file for gateway deployment is available in Invoice Manager Git repository and folder gateway. Deploy the gateway using kubectl command. Note the gateway ingress IP address and port number. We can get both from Istio Ingress Gateway Service. We will now install Prometheus, Kiali and Grafana to gather and view metrics for our Istio and Kubernetes resources. The manifest for deployment of Prometheus, Kiali and Grafana is available in Istio samples add-in folder. Run the following commands to enable Prometheus, Kiali and Grafana. After installation, start Prometheus, Kiali and Grafana server using istoctl dashboard command. You can provide any mapped or free port number. Make them run in background. From the browser, point to localhost port 3990 for Kiali dashboard. Similarly, point your browser to localhost at 2001 for Grafana dashboard. You can see dashboard specifically for Istio. We will now deploy the sample application. The deployment manifest is available in Invoice Manager GitHub source in Kubernetes folder. We will deploy data, generator, payment, and app microservice. Run the deployment using kubectl apply -r command. The deployment will also install virtual service and destination rules. View the deployed examples resources by running the kubectl get pods, virtual services, destination rules, SVC for both UI and default namespaces. Let's view the deployment in Kiali dashboard. Since Kiali is already deployed and port are forwarded, we can refresh the Kiali dashboard. We first narrow the namespaces to default and UI. Now we can see all application deployed in these namespaces. You can see each has a virtual services and destination rules associated with that. Now if you select App and look at its services and config, we can see the gateway associated with it. So if we make a curl request to gateway, it should point to the app microservice and provide its health and status. We already updated the gateway URL. Let's make a curl request to gateway URL. It routes to app microservice endpoint. Let's also call app health endpoint using gateway URL. You can see it prints the application name and version deployed. Let's run the integration test, which will perform end-to-end test invoking all microservices. First change directory to the folder Invoice Manager, then run npm install. You will only need this once. After npm has finished, let's run the integration tests. Tests are written in Node.js Cypress framework. Note Cypress prefix before the environment variable. One of the tests is expected to fail as version expected to be 1.1. Let's do a live version update while application is still running. We will deploy a canary version, that is, version 2, and split the traffic 50-50 between current and canary version. Run the deployment using kubectl, apply -r command using the deployment manifest in Invoice Manager /Kubernetes/app v2 folder. A new version of app microservice is deployed with the traffic distribution of 50-50 between canary and legacy version. We will now run integration tests to verify the deployment. Integration test should all pass. If you look at Kiali dashboard, you can see traffic split between canary and legacy version. We can now shift 100% traffic to new version and start undeploying the legacy version. Just rerun the integration test after undeployment. Before undeploying the current version, shift all traffic to new canary version. For this update the virtual service, use the manifest in Invoice Manager /Kubernetes/app v2 full traffic. Update using kubectl apply command using this manifest file. Traffic will now get diverted to the new version. Let's now run integration test again. Check the Kiali dashboard and check the traffic diversion. There is no traffic on old version. Now undeploy the old version using kubectl delete command using the manifest file of Invoice Manager /Kubernetes/app/deployment file. Check by running the kubectl get deployment command. We will not see any v1 version. Check using Kiali. The version for app microservice is v2. Check the traffic graph also. To conclude, Istio offloaded all communication, traffic, security-related issues to a sidecar envoy. Application microservices do not worry about routing, communication overheads, and security. Istio facilitates silent application upgrade without affecting traffic. By controlling traffic volume, it is possible to do live testing of Canary features. Istio and Envoy is a cloud-native offering and is open source. Some popular commercial service mesh are HashiCorp Console, AWS App Mesh, ConConnect, etc. We have now reached the end of this presentation. Feel free to leave any comments. Thank you for watching.